So in type 2c, first we are going to check the partial derivative of n with respect to y minus partial derivative of n with respect to x upon n. So what is partial derivative of m? We just found out it as minus x plus 2x square y, and this minus sign. And what is partial derivative of n? Partial derivative of n we just found out as 3x square y minus 2x upon what is n? N from the equation is x cube y minus x square. So if I take this negative sign inside, so our equation will become minus x plus 2x square y minus 3x square y, and this minus will become plus, so 2x upon x cube y minus x square. So now what we are going to do, this plus 2x and minus x, so 2x minus x is nothing but x, and minus 3x square y and plus 2x square y is nothing but minus 3 plus 2, so minus x square y upon this value. In the numerator we will take x common, so we will get 1 minus xy, and from denominator we will take minus x square common, so then it will become minus xy plus 1, which is nothing but 1 minus xy. So if we cancel these two, we can cancel these two values and we can cancel 1x. So we will get this value as minus 1 upon x. So as you can see, this value is nothing but contain only x. So this is nothing but the function of x. So this is function of x, f of x. So this is a function of x. So our integrating factor is nothing but e raised to integration of f of x into dx. So now we are going to find the integrating factor. So integrating factor is e raised to integration of f of x into dx. What is f of x? F of x is nothing but, we just found as it is 1 minus 1 upon x. So f of x is minus 1 upon x. So e raised to integration of minus f1 upon x into dx. Minus is constant, so it can be taken out of the integration sign. And integration of 1 upon x is nothing but log of x. If I take this minus sign here, like we know that e raised to a log of x can be represented as e raised to log of x raised to a. In this, here a is minus 1. So here a is minus 1, so we can represent it as e raised to log of x raised to minus 1. We know that this is nothing but e raised to log of x is nothing but x, because this exponential and log can be replaced by only this x. This is the property of log and exponential. So this is nothing but x raised to minus 1, which is equal to 1 upon x. So our integrating factor is 1 upon x. Now we are going to multiply this integrating factor with the given equation. So this is our given equation, and we multiply the whole equation by the integrating factor, and integrating factor is 1 upon x. So it will be multiplied with all the terms, which is 1 upon x minus x by y upon x plus x square y square upon x, and this whole term into dx plus x cube y upon x minus x square upon x into dy equal to 0. So this will remain as it is. Then we have this x can be cancelled out, so we get minus y, 1x from here and x from here, so it will be xy square, which is equal to dx plus this x and 1x from here, so it will be x square y, and 1x from here and 1x from here, so it is minus x into dy equal to 0. So now these two are our new m1 and n1, and again we are going to find the partial derivative of m1 with respect to y. Here the x will be constant, so 1 upon x is constant, so it will be equal to 0. So and derivative of y is 1 plus x is constant, so it will remain as it is, and derivative of y square is 2y. So this value is nothing but minus 1 plus 2xy. Similarly, we will take the partial derivative of n1 with respect to x. Here y will be constant, so y is constant, it will remain as it is, and derivative of x square is nothing but 2x, and derivative of x is nothing but 1. So from these two equations we can conclude that partial derivative of m1 with respect to y is equal to the partial derivative of n1 with respect to x. So this equation is exact differential equation. For exact differential equation, the solution is given by integration of m1 treating y as constant into dx plus integration of n1 neglecting all terms of x into dy equal to some constant. So what is m1? m1 is nothing but 1 upon x minus y plus xy square into dx, and n1 is x square y minus x into dy equal to constant. So in this we will neglect all the terms which has x, so this term is whole neglected and this is also neglected, so basically this term is nothing but 0. Okay, so we are remained only with this term, and in this term we will consider y as constant. So integration of 1 upon x, I will take integration sign inside the bracket, so it will become integration of 1 upon x minus y is constant, so it can be taken out of the integration sign, and integration of dx plus y square is constant, so it can be taken out of the integration sign, and integration of x dx equal to some constant. What is integration of 1 upon x? Integration of 1 upon x is nothing but log x minus y remain as it is, and integration of dx is x plus y square, and integration of x is x square upon 2 equal to c. So this is the solution of this problem, and this is how we solve the problem on type 2C. More such problems we will see in our next video. So stay tuned for our future lectures.